So hello everyone. Welcome to Skill Inspirational Academy. And today I am gonna discuss Palo Alto interview question. Then this is the session number one. Okay. So let's suppose you have went for an interview and like interview have asked one question, which is what is virtual wire mode in Palo Alto? What are the use cases for that? Right. If someone have asked this question, now how you will explain? So the thing is, if I'll talk about the virtual wire mode, so the thing is Palo Alto have a different kind of deployment mode. So first mode is your tap mode deployment. Then we are having vWire deployment, which is your virtual wire deployment. We have a L3 deployment mode and L2 deployment mode. Okay. So let's suppose I am having a some kind of network which is where I am having my firewall here. This is any firewall. Maybe it's a like legacy firewall. I'm having internet service provider here. Behind this, I'm having connectivity with the internet. After that, I'll have one L3 switch here. Behind this switch, I'm having some L2 switches. Or we can say I'm having some VLANs or some kind of subnets. Okay. Now, this is a legacy firewall, right? So it can only inspect the traffic on the basis of layer 3 and layer 4 information. Okay. Which means it can inspect the traffic on the basis of IP address and your port numbers, right? But n- now there is a one requirement. You want all the layer 7 functionalities, like you want the antivirus protection, anti-spyware protection, vulnerability protection, data protection, file protection, all these layer 7 kind of functionality you need, right? If you need this kind of setup, and what is the requirement here? You are also running some kind of routing protocol between this segment and this segment, okay? And there's requirement you don't want to change any kind of routing between this segment, and also you don't want to modify any kind of IP schemes whatever you are using, but you just need a layer 7 functionality. So in that case, what we will do, we will place our firewall into vwire mode. And in vwire mode, what we used to do generally, we will just cut this wire into two pieces and we will put our firewall here. This is my Palo Alto firewall, and I'll just connect one part of this particular wire here, which is Ethernet 1/1 interface, and another part of this wire with another interface of my firewall, which is Ethernet 1/2. And after that, I'll just configure all the security policies, all the security profiles into my firewall. And now all whatever traffic is flowing from this network to this network, or the traffic is coming from internet till your end users, all this traffic going through your Palo Alto firewall. Now Palo Alto firewall will do the inspection. It will inspect the traffic. Okay. S- So if you have seen this particular design here, it's a similar kind of design, guys, where I am having my router, then internet, I'm having my servers now, and I also have here layer 3 switch. Okay. Some kind of routing protocol is also running between these two devices. Okay. And they don't, if we don't want to modify any kind of, we can say, IP schemes or routing things. In that case, we will just put a firewall into a vWire mode. So in vWire mode, typically what happens, whatever traffic my firewall receive into this interface, it will just inspect this particular traffic against the security policy, security profiles, and it will just forward that traffic to the another interface. Okay. So the thing is, to when we deploy this firewall into vWire mode, generally we have to we need a two interfaces. Okay. And we need to put these interfaces into a zone, and we can just give this interface like inside zone, this interface as a outside zone. Okay. And after, we also needs to create a one virtual wire group, and we needs to basically put both these interface into that group. Okay. So like that we will do the configuration of this particular vwire deployment. This particular deployment is also known like, because we are just cutting a wire into two pieces, right? So this kind of deployment is also known as like bump in the wire. Means we are just doing a bump in and wire. Okay. Bump in the wire mode. This mode is also known as like transparent mode deployment, because these two devices is not aware about this firewall. We don't need to configure any IP address on these interfaces of this firewall. So these two devices not aware about there is a one device. So generally this device is like transparent to the network, but By putting this 5 into this mode, we are getting the layer 7 functionalities, guys. Okay. Now, why basically vwire mode come in a picture? Because the thing is, before that, you need to understand what is tap mode. So in tap mode, what happens? You are having your firewall here. You are having internet service provider. You are having your layer 3 switch, which is L3 switch. Behind this, you are having your L2 networks or your VLANs. Okay. Now, the thing about having in tap mode, what we used to do, we have to put a firewall in a side and we have to configure the spam. We have to configure the spam technology on this particular switch. So whatever traffic is flowing through this interface or receiving into this interface, all copies of this data going to the firewall, and firewall just do the monitoring, right? He will just monitor this particular traffic. So the thing is, now if you now the thing is, it's a upgrade. Like tap mode upgrade is your vwire mode, where we are putting a firewall into inline mode, and it will basically do the inspection for that. Okay, so this is your vwire mode, and these are the use cases also. These are the use cases where we will generally implement this particular mode. And if I log in into my firewall, okay, this is my firewall. So typically what I have to first go to into my interfaces, okay, and I have to choose this interface type as a virtual wire. I'll go into this interface as well, and I'll just choose this interface as a virtual wire. After that, I'll just go to into zone, and I'll just create a, I'll already have an inside zone and outside zone, but what I will do, inside for vwire, I will just create a separate zone for vwire, and I'll just select the type is virtual wire, and I'll just call these interface ethernet 1/4. I will make as a like as a inside vwire interface. Okay, I'll create one more zone which is outside vwire. This just a name, outside vwire. Type is virtual wire, and after ethernet 1/5 I will call, click on OK, and after I'll go into virtual wires. I'll need to create a virtual wire group actually. So v wire group, I'll just create this group, and I'll just call my interview ethernet 1/4 and ethernet 1/5. I have to give the tag. If you are having any kind of layer 2 environment, but I'll just go with default value here, and I'll like just click on OK. Like this, I'll configure this particular mode. After that, I'll just go into my policies, and I can create my rules according to this mode. I will select my, I'll give the name like vwire. In source, I'll basically define here inside zone, outside. Like this, you can also be able to create a security policies. Okay, so this is guys your virtual wire deployment mode, and these are the use cases as well. Okay, these are the different use cases also with regards to your vwire. Now, second question is what is wildfire and how it basically, what is the operation of wildfire? Okay, so generally wildfire is a cloud cloud-based threat analysis system where what meaning? Let's suppose we are having here Palo Alto firewall. Let me just take a small this one. Let me just draw first diagram. So I am having my Palo Alto firewall here. This firewall have a connect with the internet service provider, and behind this we are having few servers. This is my LAN network. Behind this I am having some PCs. Okay, now what happens, let's suppose this particular PC is trying to download some kind of file from this server. Now when this particular file reaches to this firewall, so what happens now, my payload, let's suppose if we have configured this wildfire in my firewall, so what it will process this particular packet through the wildfire analysis. So wildfire is generally used for detecting the unknown threats, unknown threats, or we, and also unknown email links. when the email links is also known as unknown domains or unknown phishing links. Okay, whenever we receive an email, and that email maybe someone have put some kind of basically malicious, we can say he had a malicious phishing URL. So these kind of things also it will generally detect these unknown threats and email, these phishing attack, these phishing basically URLs, and it will just send this particular data towards the wildfire cloud, guys. In wildfire cloud, basically now wildfire analysis will happen. It is also known as like some kind of sandboxing. So in wildfire cloud, we have like all kind of devices, like we have like VMware devices, we are having physical devices, all kind of operating system, and on these all kind of OS, my basically that particular file, or this particular file, it will basically run, and that after that Palo Alto just observe the behavior of this file, and according to the observation, they will basically categorize this file into four types. First type is like denial, grayware, malware, or phishing. So these are the four verdict which is provided by the Palo Alto 4N file. And this particular like wildfire is just used for detecting the unknown threats, because known threats is basically detected by the security profiles like antivirus profile, anti-spyware profile, right? So here right now we are sending these files to the public cloud. We will also have a one more device which is W500. This particular device we use for the public private cloud, as a private cloud. So if we are working in a defense sector and all, in that case basically they use at this particular, we can say, private cloud. We can also set up a hybrid cloud. So my Palo to firewall the file to this particular private cloud, then private cloud further send this file towards the public cloud. That kind of things also we can do. So now let me just explain you the operation of wildfire. Okay, so the what happens when Palo Alto Firewall receives a file. Okay, so it will receive a file. Now it will just check, it will firewall just check this file, it is signed by the trusted signer or not, means if this file is issued by some kind of trusted authorities. Okay, if yes, in that case it will allow. Otherwise what, if no, then it will just calculate the hash on that particular file. Okay, he will calculate the hash on that file, and after that it will basically match this hash value with the wildfire database, or we can say wildfire signature database. If this particular hash value is matched with any of the signature, in that case, now if any signature is there, which means that particular file have a verdict. Okay, now according to the verdict, my firewall basically see if it's a benign file, which means it's a clean file, it is not having any kind of malwares, so it will just allow by the network, but allow by the firewall. If file type is a grayware, so grayware is the file type. These are the files which looks like a malware, but in actual they are also a clean file, but their behavior may be a type some kind of malware kind of behavior, right? That kind of file also we will allow. If verdict of this file is like a phishing, in that case basically we will deny. If verdict is malware, we will deny that particular file. Let's suppose this file is not seen by the wildfire, means there is no signature database for this file. In that case, it will basically now check the size of the file. If file size is basically less than whatever we have configured, because we will not send all files to the wildfire analysis, we have a some kind of size limitation. We will, if file size is maybe 2 MB, then only we will forward that file towards the wildfire analysis. So it will check that size. If file size is high, in that case basically it will not send this file for the wildfire analysis, it will just allow that file. Let's suppose the file size also comes in a size whatever we have configured, it is minimum than the maximum value whatever we have configured, so it will now send this file for the wildfire analysis. Now that file basically go towards the wildfire analysis, where Palo Alto basically perform the wildfire analysis. What they will do, they will have all kind of devices, like they are having here all flavors of Windows, all flavors of Linux on VMware environment, on basically on VMware environment, on physical environment, all kind of iOS they are having, and they will run this file into through these particular operating system, these particular against these systems, and they just observe the behavior. Okay, and after that, observing the behavior, if according to that their observation, they will basically divide this file into four types: denial, graveware, phishing, and malware. What they will do, they will inform firewall, so they will right away inform this firewall regarding the burning of this file. Okay, and they will just update the file list, and after that, so that file list they will update into the support portal, guys. Okay, and after that they will generate the signature. In case of if it's file related to malware, they will generate the signature, and they will send signatures to the firewall. So if you are having like wildfire subscription, then you will get that particular signature database immediately within 5 minutes. If you don't have a basically that particular wildfire subscription, then you will get that particular update with regards to the signature as a daily updates for your threats, guys. So for that you need a threat prevention license. Okay, and after that, basically like that, basically this wildfire operation works. Okay, for that, you if you want this particular feature, you need to implement a wildfire you need a wildfire we can say you need a wildfire license for that. Okay, if I go to into device tab, into setup, into wildfire, here the thing is, this is the wildfire.paloaltonetworks.com. This is the public cloud, guys. If you are having private cloud, you can give the IP address of your wf w500 device. Okay, wf500 device, right? These are the limits of the file. So if file type is PDF, then limit is 10240 KB. If file type is like APK, then file size is 10 MB. So these kind of basically limit is there. Okay, and after if I'll go to into objects, into wildfire, here you can just create a wildfire profiles. Okay, can define the file type and all, and after that you can just call this profile into your security policies. Like that we will basically do the configuration of wildfire. So generally wildfire, basically the main objective of this wildfire is to protect your organization from the real time attacks or from the unknown attacks about which your organization is not have any kind of signature on the firewalls, and or maybe your organization is not aware of these attacks, right? So some kind of unknown kind of attacks it will prevent. Now third question is, what is the difference between virtual router and virtual systems? Okay, so let me tell you what is virtual router first. In Palo Alto firewall, if you want to configure the routing, guys, in that case what you have to create a virtual router. So the thing is, it's basically by creating this virtual router, and after you have to allocate the interfaces into this virtual router, and later after that you can basically configure the routing. You can configure different routing protocol, like it will support OSPF, it will support RIP, it will support BGP. These kind of routing protocols you can basically configure in this virtual router. Okay, so you can also have, like, let's suppose you are having some kind of setup where you are having your Palo Alto firewall. Okay, where you are having, let's suppose you are having these Ethernet 1/1 interface, Ethernet 1/2 interface, Ethernet 1/3 interface, and Ethernet 1/4 interface, right? Let's suppose this interface have a connectivity with the ISP1, this interface have a connectivity with ISP2. Okay, behind this you are having few servers. Here also you are in future. In that keyboard, you will also get a functionality like that. You can just put these two interfaces into one virtual router, put these two into another virtual router. Okay, if you want a communication between these servers and this server, in that case you can also enable the inter virtual routing. That thing also possible. Okay, so virtual router is generally used for just enabling the routing on your Palo Alto firewall. Now virtual systems. So, like if you have people having any experience working with Cisco ASA, right? And Cisco ASA, that virtual system is known as a like context. If you have worked with the router, that VRF, virtual routing forwarder. It's equals to virtual systems. BDC. In case of Linux, same thing is known as BDC. Okay. So the thing is what is the meaning of virtual system? Virtual systems are the logical firewalls. Okay. So what happens, let's say you are having very one big box, like so 50 to 100 series box. Okay. So what now you need, if you want to create a virtual system, that what you can just divide this firewall, like this is your BSS1, this is your BSS2, then BSS3, then BSS4. Like that, you can basically divide this one physical box into multiple logical boxes. And after that, these logical boxes, they are the individual firewalls. They are the individual firewalls, and after that, you can just give these firewalls to different companies. So generally, we use BSS. Let's say you are having this kind of infra where you are having one firewall. Okay, that is the, let's say, 50 to 100 series firewall. Now here you are having some server for SCL. Here you are having some server for, we can say, let's suppose Wipro. You have some server for here for TCS. Now what, and you are having connectivity like this. This is Ethernet 1/1 interface. This is Ethernet 1/2 interface. This is Ethernet 1/3 interface. Okay. What is the requirement here? SCL peoples don't want any kind of communication with the Wipro peoples through this firewall. They need that kind of segment. They don't want any kind of communication which allowed from SCL to Wipro. In that case, what they need a dedicated firewalls, right? SCL need a dedicated firewall, Wipro also need dedicated firewall, and TCS is also need a dedicated firewall, right? So what you have, but so the solution is either you can just purchase a dedicated single firewall for these three companies, or either what you can just, you are having one big box, what you can create three BSS. You create a BSS which is named with SCL, create one more BSS with the name of Wipro, create another BSS with the name of TCS, and just, so this entire Ethernet 1/4, then you are having Ethernet 1/5 and Ethernet 1/6. Okay, now you are having this kind of infra where, so this interface and this interface is a part of SCL, this interface and this interface is a part of Wipro, this interface and this interface is a part of TCS, and all these three now they are the individual firewall for these companies. But in actual, what you have done, you have created the virtual systems. So basically that is your virtual systems. Okay, means you, these are the like individual firewalls. So what you have done, you have just divided one physical unit into multiple logical units, guys. This is your virtual systems. Okay, now let me just move towards the next question, guys. So let me just get that question. The next question is, what is Uternet? Okay, so to explain Uternet, what I will do, let me just get one picture, guys, for Uternet. Okay, because I will able to explain properly by using that picture. Okay, just give me a second. I'm just fetching that picture. Okay, picture is here. So first, let me tell you what is the issue we will face in case of, if we, why we need Uternet. Okay, so what were the issues there? Okay, so let's suppose we are having our Palo Alto firewall, we are having our web servers, we are having some internal host. This is ISP. Okay, and behind this ISP, what we are having one DNS server. This is the public DNS server, just remember, public DNS server. Okay, now what we have done here actually, guys, let's suppose I am having here 200.1.1.1.10 IP address, and that IP address basically, let's suppose, is, if someone, let's suppose someone who is sitting in the internet PC1, they wants to send a request on this IP, what that request basically reaches to this file. So what I have used here, destination net in my Palo Alto firewall. Okay, now So what we have done, because this is a web server, so generally to remember these IP addresses sometimes become difficult. So let's suppose if someone try to exchange www.crnets.com, so we have just do the DNS binding of www.crnet.com with 200.1.1.10. So people, when this PC, if he wants to exchange, if he want to access this server, what he will do, he will open his browser and type here there in that browser www.crnets.com, right? So his first request go to DNS, DNS basically give the reply with that IP address, which is the IP address of crnets.com. After he will just send that request to a firewall, and my firewall receive this request on this IP, so it will just forward this request towards this web server. This is the flow which is happening from outside towards this inside network. But now we do have a few inside users, right? And now if this user who is sitting here, if he also wants to access this particular server, what he has have two ways here. Either he can access directly by putting this private IP address, right? Or the second thing, either he can just put the public IP address, or maybe he will just put the URL of that particular website, which is crnets.com, right? So the thing, when he will put this public IP address or this URL, that time this particular user will face issue. What happens in that case? Now this, if this user trying to access crnets.com, what he will type crnets.com in his browser. So the thing is that request first go to Palo Alto, then Palo Alto forward this request to a DNS, right? And that DNS server give the reply with the IP address, public IP address of crnets.com, right? Now when this particular router get the IP address of crnets.com, that public, so now this particular request he will forward towards this IP address. This request reaches to the firewall, right? Now in firewall, destination will happen, destination net will happen. So the he will create a packet like this. Okay, let me just, source IP address is 10.50.240.131. This is the source IP, and destination IP is 200.1.1.10, right? So when this request to the firewall, because on firewall we have configured the destination net, right? So my firewall just translate this IP address, right, into server private IP address, which is 10.50.240.100, right? So now this server receive a request from 10.50.240.231. This is the source IP address, right, which he received, and destination IP address he received his IP address 10.50.240.100, right? Now, now the thing what this server will do, he will just, when he receive this request, he will just reply to this particular PC directly, because this IP address, which is 10.50.240.131, is in same segment, right? So they can communicate locally. But what is happening? This PC is expecting the reply from 200.1.1.10, but he's getting the reply from 10.50.240.100. So what? It will drop that request, guys. So that is the issue we will face, right? Now, what is the solution for this one? Either what is the solution? So this server is hosted over www.cnnets.com, and public IP address for cnnet.com is 200.1.1.10. Okay. Now, either what, we can just introduce one local DNS, LDNS here. So now, whenever this server basically send a request towards www.cns.com, his request reaches to this LDNS, and on this local DNS, what we have done, we have just created one entry for crnets.com is available over 10.50.240.100, right? So the thing is what, now he can just send the direct, he will reach this server directly on this IP address, and he will give the reply, right? That is the one case. Now let's say we don't have this local DNS. Okay, we don't have this local DNS. Okay, we don't have this local DNS kind of setup is not there. In that case, basically we have to configure the Uternet, guys, to resolve this issue. Okay, because we will have only public DNS server where cns.com is this one, right? So what we will do now, when this system is trying to access www.cnet.com, what he will just forward the request over this Palo Alto firewall. So what we will do, we will configure the Uternet in this way. So source IP address he will put, which is 10.50.240.131. This is the source IP, and destination IP address is 200.1.1.10. Okay, this packet is to the Palo Alto. Now Palo Alto, what Palo Alto? Palo Alto will do the net translation. So what? When Palo Alto translates, so he will Palo Alto translate this IP address, which is the destination IP, on this IP address 10.50.240.100. This is the destination IP address. Okay, and my Palo Alto firewall also translates the source IP address with interface IP, which is 10.50.240.63, and this is the packet reaches to this server. Now when this server needs to give the reply, what? Because source is this one, so my server will give the reply to Palo Alto firewall. And when Palo Alto receive this request, with Palo Alto change this IP address with the PC IP address, and this IP address with the public IP, which is 201.1.10. So like that, basically we will solve this kind of issues by configuring the Uternet. So in Uternet, what happens? We will translate 200.1.1.10 with this IP address, and the local, or we can say LAN IP address, into the Palo Alto internal interface IP address. Okay. So like when we will do this like this, we will able to resolve our problem. Okay. So this is the Uternet, and this is the way how it works, guys. Okay. Now let me just move towards the next question, which is, so let me just write over there. Question number 5 is, what are the use of HA1, HA2 and HA3 interfaces in your, we can say, high availability? Okay. So let me just draw one diagram, guys. Here we are having Palo Alto firewall. We are having another Palo Alto firewall. Second Palo Alto firewall. Okay. Now both these firewall have a connectivity like this. This is your HA1 interface. We will have another interface, HA2 interface, and HA3 interface is also there. So generally, this HA1 interface is also known as a like control link. Okay. So the thing is, this HA interface generally we use for exchanging. They will use in high availability. They will use for exchanging the configuration, guys. So configuration replication happens through this HA1 interface. Through this HA interface, they will also exchange the hello messages. Hello message. They will also exchange the keep alive messages through this HA1 interface. So these hello message and keep alive message, they will just exchange between each other just to know other device is live or not. And they will also basically exchange these messages just to tell the state of each other. So these are the main things basically performed by this HA1 interface. So we will generally have a like HA1 interface and also HA1 backup interface just for the backup purpose. Okay. This HA2 interface is generally that interface is known as like data link. And through this interface, basically both the firewall, they will exchange the data like session information, session table details. They will exchange. They will exchange the MAC address table details. They will exchange the ARP table details. They will exchange the IPsec assay details. If we have configured the IPsec site-to-site VPN, they will exchange these details. Okay, so generally due to this HA2 interface only, we will able to configure the stateful firewall. So means if due to any reason, if this device which is in active state, if he become unavailable, then this device become active. that time basically whatever success, whatever users we are having, they don't need to initiate, we don't need to initiate the session. They will just this particular firewall just serve the request of which is coming from this PC by using these particular information, this session detail information. Okay, this HA1 and HA2 this HA3 interface generally we use when we are running firewall into active mode. And the thing is that HA3 interface just basically this interface used for exchanging the exchanging the packets between this active primary firewall and active secondary firewall. This is active primary, this is active secondary. So let's suppose, because in active scenario, one firewall become like session owner and one firewall becomes session setup. Okay, so the thing is now they will exchange the packets between these firewall who become the session owner, who needs. So let's suppose for one packet this firewall becomes session owner and this firewall becomes session setup, right? So this firewall basically just perform the all your layer 7 functionalities, and session setup firewall will perform your layer 3 to layer 4 functionalities. So the thing is, if your packet wants layer 3 to layer 4 functionality, in that case this firewall basically will work, and you are receiving the packet on this one. So that packet they will exchange through this HA3 interface. Packet reaches to this firewall. Now this firewall is, if it is like session setup firewall, so he will just process that packet for layer 3 and layer 4 checks, and after it will again send back this firewall, this packet to a Palo Alto firewall 1, and this firewall perform layer 7 functionalities. Again that packet go to here and it will just exit out from the exit interface. So these kind of information they will exchange through the HA3 interface, guys. So these are the, we can say these are. And also now I want to also tell you one more thing, guys. Here either we will have a like dedicated interfaces as a HA1 interface, HA2 interface, and HA3 interfaces. Okay, but if we can also use a data interfaces as a HA1 and HA2 interfaces, we can configure data port as well as a HA1 and HA2 interfaces, guys. Okay, and also HA3 interfaces. So these are your HA1, HA2, and HA3 interfaces in case of your Palo Alto firewall. Now let me just come back to the question number 6, guys. Question number 6 is, what is the prerequisite for HA configuration, right? So generally, if you want to put two devices into an HA peer, there is some prerequisite. So there are mainly three types of prerequisites. First one is your hardware related prerequisite, hardware requirements. Second thing is software requirements, and third thing is license related requirements. Okay, so if when we discuss with this hardware related requirement, which means both firewall will have a same model number, guys. Let's suppose we are having PA 850, then other end also need a other firewall is also 850. We will not allow to configure HA between 850 and PA 820. We will not able to configure, or maybe 860. We need a same kind of model number between both the ends, guys. Now if we are having same model number, definitely we are having same type of interface. Just remember, if we are having same model number, then we have a same number of interfaces, and type of these interfaces also similar, guys. So these are the mainly hardware related requirements. Now software related requirements we have, so means both firewalls will run same operating system, means same version of OS. Let's suppose in one firewall we are running 9.1.3 and another firewall is running 9.1.4. We will not able to we will able to configure the HA in that case, but one device go into the suspended state. So we need a same major and minor version operating system. Okay, so this is the software requirement. Now we do have a hardware requirement. We will have a like license requirement as well, which means both devices should have a same kind of license. Both devices need a same kind of license. So let's suppose your Palo Alto firewall one have a threat prevention license. In that case, Palo Alto 2 also need a threat prevention license. If Palo Alto one have a, we can say, wildfire license, then other end also need a wildfire license. If PA2 have a URL filtering license, then other five also need a URL filtering license. So these are the prerequisite for HA configuration, guys. Okay. Now let me just move towards the next question, which is your what is service route? What is service route? So let me tell you guys what happens if you know we have a few kind of server. Let's say we are having NTP server in our organization. We will have a DNS server in our organization. We have a like syslog server in our organization. We have a like radius server in our organization. We have a like LDAP server, which is your AD server in our organization, right? All these kind of servers generally we have in our organization, right? Now, there is so many things, right? Now, so the thing is, we have a like our Palo Alto firewall. That Palo Alto firewall have a management interface, and this management interface have a let's say connected with switch one. This is the management switch, okay, and this is the maybe Ethernet 1/2 interface, which is connected with your layer 3 switch, okay. Now because these are the servers, right, and maybe some point of time this switch have a connect with this L3 switch, and that switch have a connectivity with all these servers, right? So now the thing is, by default, your Palo Alto firewall, if your Palo Alto firewall wants to communicate with NTP server to for synchronizing the time. Let's suppose we have configured FQDN on our firewall. Now my firewall needs to resolve some names. Then he will send the request to DNS server. So, and also let's say my server wants to communicate with syslog, then he will basically send the syslog message to syslog server. Let's say we are using radius authentication, then my file needs to send some packet to radius. Let's say we have used the user based policies. In that case, my firewall also needs to do the query on AD server, right? So all this kind of traffic basically sent through the management interface, guys, right? All these kind of queries is sent through the management interface, and now this particular thing is known as a service route, guys, because management interface we will use for sending all these requests. Now let's suppose this is my inside network, okay, this is my management network. Now due to any reason I don't have a connectivity of this management network through these servers is only reachable through this ethernet 1/2 interface, through my through this interface in my inside network. In that case, we have to configure the service route, guys, on my firewall. So instead of, because by default my firewall uses the management port for just communicating with these servers, right? Now we will configure the service route on this one. If my server wants to communicate with NTP server, we will just point out the IP address of NTP server, and we just point out this interface. He will need to send this traffic through this interface, Ethernet 1/2. If my firewall wants to send the DNS queries, in that case, DNS is behind this interface, so we have to modify the service route for DNS server. We have to modify we also need to modify the service route in case of radius server. We have to define if my firewall wants to send any request to radius server, just forward this request through ethernet 1/2 interface. So these kind of modification we have to do into service route, and this is the thing which is basically you these are the things which we have to understand with regards to service route. Let me just show you. Just you if you go to into your device tab, okay, into services, you will see service route configuration, and see if you want to communicate with the autofocus, what it will use the default interface, which is management interface. Email DNS is right now, see I have configured one service route. If my firewall wants to send a DNS request, he will just forward through ethernet 1/2, and this is the IP address of my inside interface because I am having DNS server in my inside network, right? So like the you have for AD also because I'm also having AD in my inside network. So I just change the service route for this LDNS. Let's suppose I'm having NTP server also in my inside network. What I can just define that interface, define that IP address. That is the one thing I can do. Or either what I can also add a right click. If I want to communicate with this IP address, always my firewall forward the request to this Ethernet 1/2 interface. Instead of using management interface, it will use Ethernet 1/2 interface IP address. This is guys your service route. Okay. Now the next question is what is application identification, guys? What is app ID in your Palo Alto firewall? Okay. Or what is app ID and what is application override policy? So let me tell you guys what is app ID. So when Palo Alto basically come in the market in 2005, like Palo Alto launched in 2005, and basically that time Palo Alto is only the single fire who have a features like app ID, like content ID, and like user ID. These are the main three features which is introduced by the Palo Alto during that time. So what happens in app ID when my Palo Alto file receives a packet? Whenever my Palo Alto file receives a packet, this is PC1, this is server1. Okay. Whenever this PC wants to communicate with the server, what it will forward this request to Palo Alto. Now, when Palo Alto receive this packet, what it will just process this packet through the ingress check. Then it will send this packet through the connection setup state because it's a first packet. And after that, basically, it will install the connection into the connection table. Now, it will basically send that packet to the app ID engine. And now, basically, in app ID engine, application identification happens, guys, on the basis of signature database. So like app ID engine having some kind of signature database, so it will basically just check that particular traffic against these signature database, and it will just try to and my firewall just try to identify the application for this file. So let's suppose this server is hosted over port number 80. It's a web server, right? In that case, my firewall able to detect this traffic as a web browsing traffic. Let's suppose we do have a like torrent here. Let's say this PC is trying to access this torrent. In that case also, what my firewall basically send when my firewall send this torrent traffic to app engine, my application identification engine basically able to identify because he is having intelligence enough to identify, oh, this traffic is related to the torrent traffic. And also by using this app ID we can control the traffic on the visa applications, guys. Let's suppose we want to block the torrent traffic, we can block right away. If let's say we want to block the Facebook chat or Facebook video call, but we want to allow the actual Facebook, but we want to block the chatting, Facebook posting, Facebook video calling, audio calling, all these kind of things we can block because all these are the applications. We will just allow the Facebook base, so my users can able to access the Facebook page, but they will not able to make any kind of chats, they will not able to make any kind of video and audio calls through the Facebook. These kind of controls we will get by using the app ID, guys. Okay. So let me just explain you the application, how app ID works in your Palo Alto. So I'll just take up one picture, guys, for that. And also, let me just also explain you this thing as well, guys. What happens in Palo Alto Firewall? Due to this powerful app engine in your Palo Alto Firewall, what happens in old days, let's suppose you are having one legacy network, right? So that you are having Yahoo Messenger, BitTorrent, right? By default they used to run on port number 5050 and port number 6681. Okay, these are the default port number for BitTorrent, for Yahoo Messenger. And let's suppose if we have open port 80, so what these Yahoo Messenger or BitTorrent they can do, they can just do the is they will just scan this firewall on which basically what kind of rules is allowed, and after what they will switch their port numbers. Maybe they can start running on port 80 and basically that kind of traffic go through our firewall. This is for legacy firewalls. Okay, because legacy firewall inspect the traffic on the layer 3 and layer 4 information. But in case of Palo Alto, what happens if BitTorrent, let's suppose BitTorrent is we have allowed the DNS traffic. Let's say BitTorrent is also start using the DNS UDP 5000 UDP 5353 port number. So in that case, what my Palo Alto firewall basically detect, oh, this on the on looking on the layer 7 header of this traffic, he will get to know this is the BitTorrent traffic. It's not a DNS traffic, and it will just block right away. But here, what doing BitTorrent is running on DNS, but my firewall is basically inspecting the traffic on the basis of layer 7 information, guys. Okay, so here it will right away block the BitTorrent traffic. So this is also like this is the design where we have allowed DNS traffic, we have allowed BitTorrent traffic, right? But let's suppose through this BitTorrent is allowed, but BitTorrent is blocked and we are blocking at the IPS level in case of legacy design. But let's suppose someone is trying to send this command and control kind of attack. Maybe that kind of attack is not detected by the IPS module. But in case of Palo Alto firewall, if BitTorrent will start running on 53, my Palo Alto will block this traffic at the application level. And also if someone trying to access this particular try to exploit this command and control, he will also be able to block this particular traffic. So these kind of basically control you will get by using the application identification. Let me explain you the how basically application identification operation works, guys. Okay, so in app ID, what happens when my Palo Alto file receives a packet? Okay, what it will extract the IP address and it will extract IP and port numbers, and it will check the security policies at the connection setup level. Okay, it will check the policy at the connection setup level. Okay, and here it will just consider application is any. Okay, and after it will send this traffic. So let's suppose this policy is allowed the traffic for application is any on the basis of for source IP destination. Let's say we are having allowed rule, right? Now this traffic reaches to the my firewall. Now my firewall first check the known protocol decoder. In this particular traffic, it will just look for known protocol decoder, and it will just try to match this traffic against the application signature. For unknown protocol decoder, let's suppose there are some kind of unknown application traffic. In that case, it will just it will decode that traffic for against the unknown protocol decoder, and it will just forward this traffic for the application signature. If application signature match happens, in that case, basically, now let's suppose my firewall is basically find this is the DNS traffic, and we have allowed rule for the DNS. So my file allow this traffic. Let's suppose my file detect that traffic as a torrent, and we have block rule for torrent. In that case, it will block the traffic. Sometimes what happens nowadays, people's also like torrent and all the Yahoo Messenger, they these kind of all other malicious website, they will also uses HTTPS. So now when they will basically use as HTTPS, so when any users can connect with these servers by using HTTPS, so whatever data they will send through this tunnel, it is in encrypted form, and my firewall will not able to detect. In that case, what my firewall also do the decryption on this particular traffic. He will decrypt, apply the decryption policies, decrypt it again. It will match that policy against the signature database, and he will just forward this traffic towards for this application signature or through the app ID engine one more time, guys. And application identification happens. So it's the same thing. First traffic, they will basically match the traffic against the identified by the applicant signature. If app ID happens, then it will take the action according to the policy. If no, then it will just match the traffic against the known protocol decoders. If application match appli ID happens, then it will take the action according to security policy. If if it's let's say it's not a known protocol, now it will do the heuristic checks. Means it will just guess the application and it will use some kind of uncertainty factors and all to identify the application. For n- for for like let's say now my firewall is not able to identify as unknown traffic. In that case, that application identification as unknown, and whatever rules we have configured on our firewall, it will take that action accordingly. So this is the application over. This is the basically app ID things. This is the way how application identification happens, guys. Okay. Now let me also show you what are the things they will check. So the thing, if you have seen, this is the format for, this is the traffic for UDP. In UDP, basically these are the things checked by the firewall for. This is the application data, and this data is basically parsed through your application identification engine, just for identifying the application. In case of TCP send packets, basically this is the data which is used by my firewall for application identifications, guys. Just try to understand this thing. Okay. Now, if you let me also explain you application shift, how application shift happens, because this is also important, guys. Sometime, so what happens? Let's suppose you are sitting here, and this is the web server, and this is Palo Alto firewall, right? So what happens? Let's suppose you have just opened one URL which is www.facebook.com. So first TCP three-way handshake will complete, and after that basically your HTTP request will go till this server, right? So when this HTTP request will receive by the firewall, so the thing is my firewall detect this communication as a web browsing traffic. After that, because Facebook is hosted as HTTPS, so now they will basically switch over that particular communication over SSL, right? So now my firewall basically detect this application as a SSL application, right? After that, when you will receive some kind of data for Facebook, right? So my firewall detect, oh, this application is a Facebook application. Now later on, what you have done, you have opened the chat application on that Facebook, and you have just start chatting. So later on, this application basically detects a Facebook chat. So these kind of shift is also happens. But in here the end application is Facebook chat, right? But let's suppose this Facebook chat is not available. Okay, due to any reason you are not able to open this Facebook chat. Maybe this particular server become unreachable at the Facebook level due to any reason, right? In that case, maybe you in your logs you will see your date you in logs, basically you will see you are trying to access the Facebook base, this kind of things as well you will see. So just when you are troubleshooting, just try to make sure all these things, there's a application shift happens, guys. Okay, during the application identification. Okay, now let me just quickly explain you the application override, guys. So in application override, what happens? So let's suppose you are having few applications here. This is your F1, and this is your application 2. You are having your Palo Alto firewall, and this firewall have a connectivity with different branch offices, branch office 1, branch office 2, and branch office 3. This is your switch, and you are having, this is your app zone. Okay, just give the app zone. Here you are having your inside zone. There you are having multiple systems in your inside zone, right now. This is your switch. Behind this you are having multiple users. Now the thing is, just try to understand. Let's suppose if people who is sitting behind this branch of it, they want to access these applications, because these are your applications, guys. These are your apps, right? These are the apps created by you only for just some internal business purpose. And people who is sitting in behind your branch office, these are your peoples, right? We can trust on these. They are our employees. We can have a trust on them. So let's suppose if they want to exchange this application 1 or like application 2, what happens when my Palo Alto file receive these packets? Every time he needs to send this particular data through the app ID engine, right? He needs to do the application identification. So the thing is, but because these are your apps and these are your users, you don't require this application identification, because whenever your Palo Alto firewall forward this data through app ID engine, it will app ID engine needs to process this data, so it will basically consume some resources, and it will take some time for processing that data, right? But you have a trust on these application and your peoples, right? So in that case, you can also able to bypass this application identification engine for this particular traffic, guys, coming from these branch office users towards these your application. You can bypass the app engine completely by writing the application override policy. So this is guy your application override, where if you are having your internal applications, and these internal applications you are using some kind of internal business purpose, and these applications also is accessed by the internal users only, in that case you can just completely bypass the app id engine just to enhance the throughput and processing. We can say we will enhance the throughput, and we will also reduce the processing of app id engine. Okay, so this is your application override, guys. Okay, so this is all about today, and in next session we will take few other questions with regards to Palo Alto. If you want more details, if you want to know more about us, just visit our website, which is www.cnnets.com. If you want more updates with regards to videos and all, just check our YouTube channel, which is Network Security Training. We have another YouTube channel which is a Skilled Inspirational Academy. Here you will find different kind of videos on different technologies. So generally we will also provide trainings on multiple things, like we will have a trainings on Palo Alto Firewall, on F5 LTM, GTM, ASM module. We have a training on Python for network engineers. We have a training for CCNA, CCNP. We have a training for AWS and Azure Cloud. So we will generally provide these kind of trainings, guys. If you are looking, and also we will provide training on Checkpoint. So if you are looking for this training, you can reach out to us. If you want like our recorded videos and all, you can also reach out to us on these numbers, which is 9019232915. This is the one number. And also you will, if you will get a like our contact is in our website. So let me just go into website, click on contacts. Okay, and just go a little bit down. So you can just fill that form if you want to contact us, guys. Okay, so thank you guys for joining me today. Have a nice day. Bye bye.